So now we're talking about inverse functions. If you remember back to, old math stuff, we had x or y equals x plus 5. In the inverse function, we switch x and y, and then we solve for y, right? Well, now we don't have x and y anymore. Now we have theta and a number and yada, yada, yada. So the idea of inverses here is that we're going to switch. This would be our x, and this would be our y value. We're going to switch these. And to show that it's an inverse, we have two ways of doing this. I can say two things. I can say sine inverse of 0.5 equals theta. So if you notice, 0.5 went there, theta went there. That's all that changed, other than I also changed this guy right here. And what's happening here is this does not mean move it to the bottom. This is not a negative exponent moves it to the bottom. This is the inverse. If you remember back in Algebra 2, I would talk about this as being the inverse, where it's like when it's on the f, when it's on the function itself, it's not an exponent that moves it to the bottom. Instead, it's saying inverse, where you switch x and y. So that's one way to show inverse. The other way to show inverse is saying arcsin. And then once again, it's still going to be the 0.5 inside the arcsin, and then the angle has moved. Okay, so once again, these are both our ways that we can show inverse. And as all it does is it takes and it changes where the x and y are, the angle and the result are. It changes them. And you'll see on your calculator, you actually have a sine inverse or an arcsin button. Some calculators say sine inverse, sine to the -1, like this one. Some calculators say arcsin. But wherever you have your sine button, if you see above it, it'll do that. And so what'll happen is if you plug this in, so plug in sine inverse of 0.5, it's going to tell you either 30 degrees, if it's in degrees. If it's in radians, it's going to tell you whatever pi over 6 is in decimal form. But if you put it in degrees, so just put it in degrees right now, you're going to see that it gives you 30 degrees if you plug that in. Now, if we look at cosine, there's two ways to write cosine. So here I have cosine of the angle equals 1/3. So I can change it to an inverse. So then I write cosine inverse. Notice where the -1 goes. It goes on the exponent on the cosine, not on the angle itself, but on the cosine. And then I'm going to switch my x and y, or I'm switching my angle and my answer. So it's cosine of 1/3 equals the angle. So once again, the 1/3 went over there, the angle went out there. And now you can plug this in your calculator and see what you get. I don't know that answer. Or I can write arc cosine of 1/3 equals the angle. Okay, and so you plug that in, you'll get your answer. It should be somewhere, I don't know, somewhere around 60 degrees or something. It's less than 90, but more than 45 probably. I could be totally wrong. But anyway, so that's what arc cosine looks like. And then we have tangent. Now tangent, same thing. Actually, there's nothing really all that different. We have tangent inverse, then we can put the 5 there and we get an angle. So once again, these get switched around. Or we can write arctan of the 5 equals the theta. But anytime you see these, whenever you see this, no matter if it's sine, cosine, or tangent, this is not an angle. This is that fraction answer that we usually get. The angle is on the other side of the equal sign. Okay, now another thing that we have to talk about is when we're doing this, your calculator is only going to give you one answer, but if I draw, it's hailing out right now, that's interesting. If I draw the unit circle, right? So let's just look at sine of an angle equals 1/2. Okay, sine of an angle equals 1/2. That's going to happen at 30 degrees, right? So then that means I should say sine inverse of 1/2 then equals 30 degrees. But you know what? That's not the only answer. Because I could also say over here at 150 degrees, it also equals positive 1/2, doesn't it? Right? Positive 1/2 here, positive 1/2. We're talking about the y value. The y value is short guy, and it's positive. So I can also say it equals 150 degrees. But That's a problem. I don't want two answers, then it's not a function, right? And if it's not a function, we can't use it. And so what we do is we restrict the domain. Whoops. So we restrict the domain. Okay? Now for sine, if we were to do first quadrant and second quadrant, then we would get our two answers, and that's not good. Plus, we would never get any of our negative answers, like negative 30, things like that. So what we do is we're going to restrict it to the first and the fourth quadrant. Okay? So sine is in the first and fourth quadrant. So this is the picture I like to use right here. First and fourth quadrant, that's where I'm going to use sine. And if I'm looking at a positive 1/2, it's 30 degrees. But let's say I'm trying to find sine inverse of negative 1/2. Sine is a y value. Negative 1/2 means it's down here. So then that is going to be, I'm not going to say 330 degrees. What I'm going to do is I'm going to say negative 30 degrees. So instead of using the full circle, and saying, hey, I'm going around, but then I'm not going to go around here, and I'm going to go around here again, instead of saying, hey, I'm going here, and then I skip to going here, I'm not doing that. What I'm going to do is I'm going to say I'm in the positives, and then remember how if we go in this direction, we can look at these as negatives? And what that does is it connects them this way, instead of connecting them, skipping, and then joining in again. So we're looking at it as going this way. So then we say it's going from negative 90 degrees to a positive 90 degrees, so it's connected here. So then that means if I'm looking at sine of negative 1/2, or sine inverse of negative 1/2, sorry, I'm going to say negative 30 degrees, not 330. Okay, so that's sine. Sine is in the first and the fourth. Okay, what about cosine? Do my unit circle again. Cosine is the x value, right? Cosine is the x value. So I'm looking at the x values, and if I were to do like sine, if I were to go in the first and the second, then my x value here would be root 3 over 2, and my x value here would be root 3 over 2. I would have two angles that give me an x value of root 3 over 2. So I can't be there. For cosine, instead, what we're going to do is we're going to do the first and the second quadrant. Okay, this is cosine. Cosine's first and second. Nope. So cosine's a first and second. And so this one's actually a pretty straightforward one. So if I want cosine inverse of negative root 3 over 2, okay, I'm looking at cosine's the x value. It's a big x value, and it's negative. So in this quadrant, it's negative. Negative root 3 over 2, I want it to be big. So cosine, this is going to be, what is that, 150 degrees. I don't have to worry about any negative degrees. I'm just going straight from this first quadrant to the second quadrant. It's pretty straightforward. So cosine is the first and second quadrant. And then we have tangent. Now tangent is just like sine. So tangent is going to be restricted in the first and the fourth quadrant. Only in the fourth quadrant is going to be the negative numbers. The negative 30, the negative 50, the negative 45. Okay? So tangent is first and fourth quadrants for tangent. Okay, let's look at some examples. So I want the arcsine of root 3 over 2. So what I'm going to be doing is I'm going to be giving an answer in degrees. I'll choose degrees here. You'll be told what to give it in. But I have to first, I'm going to draw the unit circle, and you may or may not do this, but if you're struggling with this, of course, draw the unit circle. I want it to be a positive. Now remember, sine is in the first and the fourth. And because this number right here is positive, I'm going to be in the first quadrant, and sine is the y value, and it's root 3 over 2, which means it's a big one. So here we are at root 3 over 2, and so my angle there is 60 degrees, right? Because it's tall, it's away from the axis, so it's 60 degrees. Now, I'm using numbers right now, root 3 over 2 and 0 and things like that. Those are numbers that we know on the unit circle. So if we have numbers like that, I expect you to use the unit circle and not a calculator. But sometimes you're going to get problems where you don't have the unit circle numbers. And then you have to use a calculator, and so you'll use those buttons on your calculator to figure it out. Make sure you know if it's in degrees or radians, though. So what about cosine? All right, so cosine is in the first and second quadrant. Cosine is the x value. And it's saying, when is the cosine inverse equal to 0? So when is the x value equal to 0? And it's going to be right up here at 90 degrees. So your answer is 90 degrees. Okay, I have 2 more examples. So this tangent one's the more difficult of them all because we have some math to do. Okay, so tangent, remember tangent is in the first and the fourth. And it looks like tangent inverse is going to be positive, so it's going to be in the first for sure. And we have to figure out when is tangent root 3 over 3. So it's either at the 30 or it's at the 60. Remember at the 30, this is y divided by x. At the 30, the y value is 1/2, and the x value is root 3 over 2. Okay, so now if I simplify that, the denominators cancel. So now I get 1 over root 3. And then I have to rationalize that. And so then I get root 3 over 3. So we guessed it right the first time off. I did 30 degrees. So tangent inverse of root 3 over 3 is 30 degrees. Now for arc cosine, we want it to be 1/2. Remember, cosine is in the first and second quadrant. Now arc cosine is 1/2. That's positive, so that means we're going to be in the first quadrant. We want the x value to be 1/2 because cosine is the x value, and 1/2 is the short one, so we're going to be up here at 60 degrees. All right, so arc cosine is 60 degrees. So that is how you find inverses at a basic level. You want to make sure you have this down pat before you move on to the next stuff. Good luck, and ask me questions if you have any.